Okay, hello everybody. I'm just going to make a video going over some fuse block basics, important things to pay attention to when you're assembling these or putting these together. Because I see a lot of people make mistakes when it comes to fuse blocks of all kinds. And I'm just going to use this because it's a universal unit. These are great for under the hood where you have water and moisture because they're all sealed up as far as the main fuse portion of it. Not so much the wire, but that's really not a problem. Anyway, let me start off. I'm going to swap out these sort of generic, cheap 300 amp fuses for some ceramic units. Basically, I'll pull these out. And the thing I want to emphasize is the contact area going on here. And I'll show you in a minute. You have to be careful with these once they're out because the only thing keeping them from flexing is the fuse itself. So hold it by the steady end pieces here as far as tightening and loosening the fuses. Come right out. Okay, the thing about these, I don't know what these are actually made of. They might be brass, but they do have a really nice plating. I wanted to emphasize how important it is that these be nice and flat. You could probably run like a straight edge across them, or just use your finger to feel that there's no burrs or anything sticking up, because you have these threads cut in there, and if you have a burr sticking up, it could cause the fuse to, let me get a little close up. You don't want your fuse sticking up like that at all. It needs to be completely flat so you have maximum contact. And we're going to take, let's see which way I installed the previous ones. Okay, I'm going to install it like that. Anyway, the way the screws stack up, you've got a flat washer. And the way these are made is it's just stamped out. Have a big machine, pushes the material away, stamps it. So you have a smooth side, smooth edge on this side. And this where the stamping came through this direction. So you have a burr. I don't know if you can see that. But you have a burr edge on the top and a smooth edge on the bottom. So you want to use this smooth edge. You know, it's smooth in the center and smooth on this edge. And then you can feel the burrs on this side. So you want to make sure that the smooth edge is what's going on top of the fuse blade, so that it's going to be nice and flat and make maximum contact. And then your other pieces is a little lock washer. That's pretty much it. We're going to get these assembled. And these do have a nice finish. I don't know what material the body's made of, but this protective, I think it's anodizing. It's really good stuff. Okay, now it is important that you don't just haphazardly put this together. If you're not paying attention and you end up with this type of scenario, you put the washers in the wrong position and tighten it down. First of all, you can see the gap underneath the fuse around the edges. You're not getting 100% contact. And then if you look on the top, you can see how the little lock washer, way less contact area. So this is going to have a lot of resistance. It may be fine at lower amperage loads, but you start putting like an actual 300 amps through this, the lack of contact, or the reduced amount of contact, is definitely going to cause some heat. These things are going to start to heat up, and it can cause the plastic housings to melt, essentially. I'm sure we've seen pictures of fuse holders melting. This is one of the reasons. You want to have, when you start pushing high current, big amplifiers, you have to be very mindful of heat. You have to pay attention to everything. If you're only putting like 50, 80 amps through these, it's probably not going to be that big a deal. It's not going to get too hot. But with high current stuff, you have to make sure everything is just right. Get the order. See how we have the fuse directly on the base of this metal piece. Washer, the flat washer on top. We're gonna go ahead, clamp this down. And I know this video is kind of long, but we're essentially going to hold it. There we go. So I can feel a little bit of tension. That's the lock washer starting to compress. Going to bring it down. Okay, feel it snug up. That means the lock washer has fully compressed. Make sure it's lined up. Going to look at it, make sure it's not crooked. Double check the work. And we're going to give it a little extra, I definitely felt it tighten up and get firm. Boom, just like that. It's not massively, you don't want to strip these threads out. But yeah, you definitely want to get it nice and snug and tight, to where it's not going to, over the years, being around the engine bay, vibrating and stuff, you don't want any of the stuff loosening up. You want it to stay nice and reliable. And I'm checking on this side. The washer's actually upside down. And if you didn't really understand what I meant by the burrs, you can see that's a sharp edge, rounded. You don't want to put the sharp edge against the material. Now when you put a lot of clamping force, it's probably going to push the burrs down, push them away so that you get good contact. But ideally, just flip it over. That way you've got the nice flat side pressed right up against there. Make sure you've got your lock washer. Oh, that's right. I was just using that as a demonstration. Hopefully this is all going to be in focus here. It's like if I went through all this problem or effort and it was out of focus. Okay, you don't want that. You see what happened there? Looks good on this side. Bam. No go, man. That's bad. That's gonna cause you some serious problems. There we go. Now we're looking good. And I don't mean to be going over such a basic, simple concept, but there's some people that just don't understand the physics of what's going on. They don't understand the importance of contact area, and then they have problems down the line and they don't understand what's going on. So I'm just trying to help them out. Oh yeah, the lock washer's compressed. It looks nice and straight. We're gonna hold it here on this piece. Yeah, you don't want to crank it down, holding it like this, because the only thing that's holding these together, holding them straight, is the fuse itself, which can flex. So just hold it by the base when you crank these down. Bam, 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 bam. Oh yeah. Looking good. Now these things are kind of interesting. These are generic type fuse holders. You see the little notch cut it on this side, notch cut it on this side, and notch on the bottom. Those basically just line up with the fuse. So when it goes in, spins around, it'll only go in one way. The fuse is what locks it into position. And then you've got these extra notches. See that extra notch there? That's just in case the screws are kind of long. That allows it to slide in. Push that in there nice. Slides right in. Got fresh O-rings. Now these O-rings do wear out over several years. I was basically using one of these type of fuse holders in my vehicle for about 12 or 13 years and had really good results. At some point the O-rings did let me see, the threads are a little wonky. Oh, they weren't started yet. Okay, now we're good to go. Yeah, sometimes these O-rings will go out after 6, 7, 8, 9 years. Depending on where it is under your hood. You may not, if it's not around water, you're okay, but you can replace the O-rings if they do go bad. The whole point of this is just to keep this portion, everything around the fuse, keep the water off of it. Because even though you've got gold plated fuse, and this is probably like nickel plated or maybe a cadmium, I'm not sure what coating they use. But yeah, it's all coated, it's all clean. You obviously don't want any grease. Well, I shouldn't say grease, but you don't want any debris or dirt in between the contact areas. And that's pretty much it. You're good to go. Oh, I will point out a trick, because most people are using this size. They're using 0 gauge, but there is a trick to it. It's very simple. You figure out the length you need to cut. You try to cut it so that it goes, the metal portion of your wire goes all the way to the end, and then your insulation will tuck right in. That's what you try to do. Depending on the wire, if the insulation is too big to fit in here, that's okay. You can have the insulation go up to here, but just make sure that the actual wire goes all the way down and touches the base of where it's drilled. Don't cut your wire that long. Cut it so it goes all the way down, all the way. That way the screw can clamp it. Now you can put a ferrule on it if you want, or you can just run raw metal, tuck it in there, and this is the trick. Once it's in there, you crank it down. You're going to feel it tighten up. Get it kind of snug, and then take your wire, wiggle it around like this. That causes the strands to kind of move around and settle and get rid of some of the air, and you'll notice this will loosen up. So you crank on it, get a little extra movement. You probably do about that much extra. Wiggle it again, you'll feel it start to get real tight. Snug it up again, take out the slack, tighten it a little more, and then by the third or maybe fourth time, you'll feel it. Those strands will be in there nice and solid, and you won't have any movement, and you won't be able to tighten it anymore. Now this is a beefy unit with thick threads, so I don't think you're going to have to worry too much about stripping it, but you don't have to put like a gorilla crank on it. Just as long as it's, I don't know, just strong enough not to strip the threads on it is the main thing. You strip the threads, you're going to spend another $30 replacing it. But yeah, when you do that little technique of letting the strands sort of wiggle around and retighten it, You're not going to have any problems with it. I mean, you could come back after a few weeks or a month and just check it. You know, it doesn't hurt to check. But that's a technique that I've developed over the years. It works great. And let me wrap this up. 15 minutes, holy cow. Yep, there you go. Mount this someplace solid, or if it's dangling, at least put something soft so that it would touch something soft, and then zip tie it in place, just so it's being held and it's not going to be like rubbing up against metal or hitting metal. But yeah, that's about it. Thanks for watching. Hopefully it helped somebody out. Yeah, and there's the idea of switching between like really cheap fuses and a more high quality fuse. That's another subject for a different day. You can go over to Glowforge. They have a YouTube channel, or excuse me, not Glowforge, Glow Voltage. Yeah, don't know if you can see that. There you go, Glow Voltage. Going to be using a couple of their fuse blocks. Nice little units, super cheap, like 20 bucks. Anyway, let's cut it here. Thanks for watching. Hope it helped somebody out. Hope you learned something. Till next time. Later.